Hey, grade 8s, hope you're doing well. Today we're talking about force, pressure, and area. This is part of our Science 8 Mechanical Systems. So let's begin with some pressure, in which pressure P is the force F acting over certain area A. So pressure is the force acting over a certain area. We can calculate pressure by using the formula pressure is equal to the force over area. So P equals F over A. And force is measured in newtons, which is N, and area is measured in meters squared, which is M squared. We did talk about this a bit in our mix and matter unit, and so this should look a little bit familiar. So with all this, that means that pressure is measured in newtons per meter squared. This is also known as pascals, which is measured, which units is PA. We have a video here, which is a bed of nails. So I'm going to leave this to you to go check out on your own in the slides. Essentially what it is these guys are going to play with a bed of nails and a balloon. So if you have, I will just pull out a pen here quick. Just give me one moment, pull the pointer. And so if you have, didn't work. Anyhow, if you have one nail and you have a balloon and you poke the balloon with that nail, the balloon will pop. What they're showing here is that if you have this bed of nails, all these nails pointed in, we have that pressure exerted over an area. So it actually causes the balloon not to pop once it makes contact with the nail. So definitely go check that out. We're going to keep moving though. People have designed equipment based on the theories of pressure to help protect people from injury. For example, there's football with pads, helmets, same as hockey protective equipment, your padding, your helmet, airbags, and then we also have boxing gloves. So that if we essentially, like if you think about boxing gloves, what you're doing is that you're exerting a larger area. So that means that there's less force being enacted. Also, too, there is that cushioning in there as well. So this is a guy named Pascal. We're going to talk about his law, so Pascal's law, which states when pressure is exerted on a contained fluid, the pressure is transmitted equally in all directions perpendicular to the walls of the container. Blaise Pascal also observed that the shape of the container had no effect on the pressure at any given depth. So we're going to take a look at this, and what it says is that Pascal's law helps us develop and explain why machines, such as a hydraulic lift, work. So here we have the original force. Force is calculated by going pressure times area. So the formula listed here. We have an area here that's being pressed on, and pressure 1 is calculated as force over area. And Pascal's principle here, as we said, is that pressure here is equal to the pressure here. So what happens is that our pressure remains constant, but our area has now increased by 10. So the area is multiplied by 10. And what causes that to happen is that pressure 2 is equal to F2 over A2. So F2 is equal to pressure 2 times area 2, which is equal to 10 times the force of force 1. So the second force is 10 times the original force. So for a hydraulic system to work, it must be a closed system. This means that nothing can get in or out of the system. If the system has a leak, it will lose efficiency, which we've talked a bit about, and we've already looked at a bit yesterday. But if we look here, though, we have this piston here. No, it's not piston. But we apply this force here, and what happens is in this hydraulic system is we press down, and the fluid's going to get moved over here and push up. And because we have this larger area, it actually causes our force to be increased 10 times. Hydraulic systems work because a small piston, can generate a force that is then transmitted to a larger piston. So we have the two pistons back here. This piston, smaller piston, and the larger piston on the right. Hydraulic systems work because a small piston can generate a force that is then transmitted to a larger piston with the same pressure but applied over a larger area. For example, here we have pressure is equal to force over area, and we applied 500 newtons of force over an area of 5 centimeters squared. 500 over 5 is 100 newtons per centimeter squared. That's our pressure. Then what happens is we have our large piston, and we increased our area, in which we have our force is equal to pressure times area, and we have 100 newtons per centimeter squared. multiplied by 50 centimeters squared. Multiply those together, we get 5,000 newtons. So this system increased the force by a factor of 10, as we saw in the last image. We're talking about hydraulics and mechanical advantage. To calculate the mechanical advantage of a hydraulic system, you apply the same formula that you learned at the beginning of the unit. So our mechanical advantage is load force over effort force. For the previous example, 5,000 newtons over 500 newtons equals 10. Note, in a hydraulic system, the distance that each piston moves is not equal. For example, in this example, the small piston would need to move 10 meters to lift the large piston 1 meter. Let's just go back. So this piston on the left here has to move 10 meters for this to move even just 1 meter. Okay? And your assignment, which is investigation 4F on page 310. Good luck. If you have any questions with that, let me know and I'll be glad to answer. Take care, folks.